Runtime OS. Why an OS is becoming critical in the AI era. AI is fundamentally different from traditional software. For years, we have focused on making AI smarter, building larger models, training on more data, generating better answers. But as AI begins operating inside businesses and society, an entirely new set of challenges emerges. Which AI model should be used? Which data should it access? When should a human make the final decision? And ultimately, who is responsible for the outcome? AI alone cannot coordinate all of these execution processes. That is why we now need a new layer above AI itself. We call this layer Runtime OS. Runtime OS integrates AI models, data, applications, cloud infrastructure, hardware, and security into a single execution platform. Its purpose is not to make AI more intelligent. Its purpose is to make AI operate safely, reliably, and in a trustworthy manner. In the AI era, the question is no longer only how to build intelligent models. The question is how to operate them responsibly in the real world. That is why operating systems are becoming essential once again. Let's explore why Runtime OS will become one of the fundamental infrastructures of the AI era. AI is no longer just a chatbot. Until recently, AI was primarily a chatbot. Its role was simple: to answer questions, write documents, summarize information, and translate languages. But today, AI is rapidly evolving into something much more powerful. AI can now call APIs, execute complex workflows, coordinate with multiple AI agents, and even interact directly with external systems. In other words, AI is no longer just generating answers. It is becoming an execution system. This shift changes everything. The challenge is no longer simply building smarter AI models. The real challenge is designing an environment where AI can execute actions safely, reliably, and under proper control. Because once AI begins making API calls, launching workflows, and operating real-world systems, execution itself becomes the critical issue. That is exactly why we need Runtime OS. Runtime OS provides the execution environment that allows AI to operate securely, coordinate with surrounding systems, and remain under human governance. The future of AI is not just about intelligence. It is about safe and trusted execution. Early computers faced the same problem. What we are seeing today is not entirely new. In fact, the history of computing has already faced a very similar challenge. As computers became more powerful, more and more programs began running at the same time. Multiple applications competed for the CPU. They shared memory. They accessed storage. They communicated through the network. Without proper coordination, these programs would interfere with one another, creating conflicts and instability. To solve this problem, a new layer was introduced: the operating system. An operating system manages shared resources such as the CPU, memory, storage, and networking. It isolates programs from one another and provides a safe environment where multiple applications can run simultaneously. That is why today we can open a web browser, edit documents, play music, and run dozens of applications at the same time without worrying about resource conflicts. Now, the AI era is beginning to face the same fundamental challenge. The difference is simple. The objects being managed are no longer traditional software programs. They are AI systems. Just as operating systems made modern computing possible, the AI era requires a new execution layer designed specifically for coordinating and managing AI. That is the role of Runtime OS. What is an operating system? So, what does an operating system actually do? At its core, an operating system manages a computer's resources and safely coordinates the execution of multiple programs. For example, it decides which program gets access to the CPU. It allocates and protects memory. It manages files and storage. And it controls access to data. An operating system also creates and terminates processes, manages permissions, and handles hardware interrupts as they occur. All of these responsibilities are coordinated by a single layer, the operating system. Because of this, multiple applications can run at the same time without interfering with one another. Your web browser, email client, music player, and development tools can all operate simultaneously, safely, and efficiently. This is the true role of an operating system. Its purpose is not to make the computer more intelligent. Its purpose is to manage limited resources and coordinate the safe execution of many independent programs. That principle has remained unchanged for decades. And it is the same principle that will become essential in the age of AI. AI faces the same challenge today. AI is beginning to face the very same challenge that computers faced decades ago. A modern AI system is no longer a single model. It consists of many different components working together. Large language models generate and understand language. AI agents act autonomously toward specific goals. Workflows execute multi-step business processes. RAG systems retrieve external knowledge. Tool calling connects AI with APIs and external services. And multiple AI agents collaborate to solve complex tasks. All of these components operate simultaneously. They communicate. They depend on one another. And they continuously influence each other's behavior. As this complexity grows, an important question emerges. Who coordinates the entire system? What happens when multiple agents compete for the same task? Who prevents incorrect or unsafe actions? How do we guarantee reliability, safety, and consistency across the entire execution process? The more capable AI becomes, the less the challenge is about the intelligence of individual models. The real challenge is coordinating the entire AI ecosystem safely and reliably. That is why the AI era needs a new execution layer. Just as the operating system coordinated software in the past, Runtime OS is designed to coordinate AI systems in the future. AI needs an operating system, not just intelligence. So what happens if AI has no operating system? What happens when powerful AI systems are allowed to execute without coordination or control? A number of serious risks begin to emerge. An AI system may continue acting in unexpected ways, with no effective mechanism to stop it. When something goes wrong, responsibility becomes unclear. Who made the decision? Who is accountable? In an emergency, there may be no reliable way to halt the system. Even worse, the reasoning behind AI decisions may be impossible to explain. As multiple AI agents work together, they can compete, interfere with one another, or create unintended behaviors. And without clear boundaries, AI may access systems or perform operations that should never have been permitted. As AI takes on more critical roles in business and society, these are no longer technical inconveniences. They become organizational and societal risks. That is why the goal is not simply to build more intelligent AI. The real challenge is building AI systems that are safe, controllable, coordinated, and trustworthy. Just as computers required an operating system to manage software, AI now requires an operating system to manage intelligent execution. That operating system is Runtime OS. Therefore, we need Runtime OS. That is why the AI era needs Runtime OS. Runtime OS is not designed to make AI more intelligent. Its purpose is to provide the execution foundation that enables AI to operate safely, transparently, and in coordination with the real world. It connects four essential elements. AI, to safely execute AI agents and intelligent systems. Humans, to incorporate human judgment, supervision, and final decision-making whenever necessary. Organizations, to reflect business goals, operational processes, and organizational responsibilities. And rules, to consistently enforce policies, governance, security constraints, and regulatory requirements. These elements should not operate independently. They must work together within a single coordinated execution environment. That environment is Runtime OS. Its role is to connect AI, people, organizations, and rules into one trusted operational platform. The future of AI is not defined by intelligence alone. It will be defined by how safely, transparently, and reliably intelligent systems can work together. That is the vision of Runtime OS, a foundation for trusted coordination in the age of AI. Runtime kernel. So, what lies at the heart of Runtime OS? The answer is runtime kernel. In a traditional operating system, the kernel is the core component that manages the CPU, memory, and other critical system resources. It is responsible for controlling and coordinating the entire operating system. The AI era requires a similar foundation. That foundation is the runtime kernel. The runtime kernel safely executes AI agents and intelligent systems. It incorporates human judgment, supervision, and approval into the execution process. It reflects organizational roles, business processes, and operational responsibilities. And it consistently enforces policies, security rules, and governance constraints. Most importantly, it coordinates all of these elements so they work together safely instead of competing or conflicting with one another. The purpose of the runtime kernel is not to make AI more intelligent. Its purpose is to control, protect, and adjust execution across the entire system. In other words, the runtime kernel unifies AI, humans, organizations, and rules within a single execution foundation. It enables safe, transparent, and trustworthy coordination across the entire AI ecosystem. Just as the kernel became the heart of the operating system, the runtime kernel will become the heart of Runtime OS in the age of AI. Event. What happens in the world? The first thing the runtime kernel does is observe what is happening in the world. We call this an event. An event is any real occurrence or change that happens inside or outside the system. For example, a user clicks a button, a sensor detects an abnormal condition, a new business process starts within an organization, a law or policy is updated, market prices change, or an AI system generates a new prediction, recommendation, or decision. From the perspective of the runtime kernel, all of these are simply events. The important point is that the runtime kernel does not focus only on AI. It continuously observes human actions, organizational activities, the physical world, laws and regulations, market conditions, and the behavior of AI systems. Every change is captured as an event. These events become the starting point for everything that follows. Before the system can make a decision, coordinate multiple agents, or execute an action, it must first understand what has happened. That is why the Runtime OS begins not with intelligence, but with events. Every intelligent execution starts with an accurate understanding of changes in the world. From signal to meaning, but simply knowing that something happened is not enough. An AI system cannot make the right decision based on raw events alone. The critical question is, what does this event actually mean? The runtime kernel continuously receives signals from the world. These signals come from users, sensors, organizations, markets, AI systems, and many other sources. It first recognizes them as events, but it does not stop there. The runtime kernel transforms events into meaning. Consider a simple example. A temperature sensor reports 80 degrees. To a computer, that is just a number, but to the runtime kernel, it becomes temperature high, not just data, but a meaningful condition that requires attention. The same applies to many other situations. A pending request becomes approval required. An unhappy customer becomes customer angry. Low inventory becomes inventory low. These are no longer isolated pieces of information. They are shared meanings that every AI agent, application, and workflow can understand consistently. This is one of the most important responsibilities of the runtime kernel. It does not simply process data. It transforms events into meaning. And once the system understands the meaning of what has happened, it can coordinate the right actions across the entire AI ecosystem. In the Runtime OS, intelligence begins not with data, but with shared meaning. State. Where is runtime now? Understanding events is only the beginning. To operate safely, the Runtime OS must also know the current condition of the entire system. We call this state. A state represents where a task or process is at any given moment. Is it waiting to begin? Is it currently running? Is it under human review? Has it been approved and is ready for the next step? Has it been stopped? Or is it recovering from an error? The runtime kernel continuously tracks these states and manages the transitions between them. As work progresses, the system safely moves from one state to another according to policies, approvals, and execution results. Because the current state is always visible, everyone can understand exactly what is happening. Where is the process now? Who needs to approve it? Where did an error occur? And from which point can execution safely resume? This visibility is essential for building trustworthy AI systems. Runtime OS does more than execute tasks. It continuously monitors, controls, and manages the state of the entire system. That is what makes reliable execution possible. Because trust is not created simply by intelligent decisions. It is created by always knowing where the system is, what it is doing, and what should happen next. Boundary. The limits AI must never cross. Making AI more capable does not automatically make it safer. The most important question is not only what AI can do, it is also what AI must never do. That is the purpose of boundaries. Every AI system must operate within clearly defined limits. Some boundaries are legal. AI must comply with laws, regulations, and compliance requirements. Some are about safety. AI must protect people, assets, and critical systems from harm. Others are ethical. AI should respect fairness, human dignity, and justice. There are also boundaries of authority. AI must act only within the permissions and governance it has been given. And finally, every organization has its own policies, business rules, and operational context that AI must follow. If AI crosses these boundaries, it no longer becomes a helpful system. it becomes a source of risk. That is why the Runtime OS checks boundaries before execution begins. Is this action authorized? Is it safe? Does it comply with organizational policies and applicable regulations? Protecting boundaries is not about limiting AI. It is about creating an environment where humans and AI can work together with confidence. Because trustworthy AI is not defined by how much it can do. It is defined by knowing exactly where it must stop. Decision. Choosing what happens next once the runtime kernel understands the event, determines its meaning, identifies the current state, and verifies all applicable boundaries. It must answer one final question: what should happen next? This is the role of decision. If all conditions are satisfied, execution continues. If a temporary failure occurs, the system retries automatically. If a higher level of authority is required, the request is escalated to another system or a responsible person. If a risk or policy violation is detected, execution stops immediately. And when the decision should not be made by AI alone, the runtime kernel requests human review. The important point is that these decisions are never based on AI's intuition alone. Every decision is grounded in the current state of the system, organizational policies, and predefined boundaries. The runtime kernel evaluates the situation and selects the most appropriate next state for execution. Its purpose is not simply to let AI make decisions. Its purpose is to coordinate AI, humans, and organizational rules so that every decision is safe, explainable, and accountable. That is what makes Runtime OS fundamentally different from a standalone AI model. It transforms intelligent predictions into trusted operational decisions. Coordination. Connecting the whole system. The challenge of the AI era is not simply running a single AI system. Real-world environments are far more complex. They involve multiple AI agents, multiple people, and countless organizational rules, policies, and procedures. If each of these makes decisions independently, conflicts and inconsistencies are inevitable. That is why we need coordination. The Runtime OS does not manage each component in isolation. Instead, it connects AI systems, humans, organizations, and rules into a single coordinated execution environment. It determines who is responsible for each task, which policies should take priority, when human intervention is required, and how multiple AI agents can collaborate instead of competing with one another. Its goal is to optimize the behavior of the entire system, not just individual components. This is the true purpose of Runtime OS. It is not simply about controlling AI. It is about enabling AI, humans, organizations, and governance to operate together as one coherent system. Because in the age of AI, success will not depend on the intelligence of individual agents. It will depend on how well they coordinate. And that is why coordination becomes the foundation of the next generation of intelligent systems. Human gate. AI does not execute everything automatically as AI becomes more capable. It is tempting to believe that we should simply let AI make every decision. But should AI be allowed to execute every action on its own? I believe the answer is no. AI is excellent at analyzing information. It can generate recommendations, support decision-making, and dramatically accelerate complex tasks. But some decisions carry consequences that go far beyond efficiency. They may affect human lives, involve significant financial transactions, create legal responsibilities, or have a major impact on society. In these situations, AI should not act alone. This is where human gate becomes essential. The AI analyzes the situation and proposes a course of action. If the runtime kernel identifies the decision as high risk, execution pauses. A human reviews the recommendation, verifies the context, and makes the final decision. Only after human approval does the system continue. The final authority, and the final accountability, remain with people. Human gate is not designed to limit the capabilities of AI. It is designed to combine the strengths of AI and human judgment in a safe and responsible way. AI provides speed, scale, and analytical power. Humans provide context, ethics, responsibility, and accountability. Together, they create a system that is not only intelligent, but also trustworthy. That is the role of human gate within the Runtime OS. Execution. Turning decisions into action. Making a decision is not the end of the process. A decision creates value only when it is carried out in the real world. This is the role of execution. The runtime kernel first determines the best decision. It then translates that decision into a specific action. But execution is not limited to a single method. Depending on the situation, the Runtime OS selects the most appropriate way to act. It may call an external API, control a robot or a physical device, launch a business workflow, send notifications to people or other systems, or update a database by storing, retrieving, or modifying information. Each action is chosen deliberately to achieve the intended outcome safely and reliably. Execution is the stage where decisions become real-world actions. This is what makes Runtime OS fundamentally different from a standalone AI model. It does not stop at generating recommendations. It ensures that every approved decision is executed safely, consistently, and in a way that can be explained and audited. Because intelligence alone does not change the world, execution does. And the mission of Runtime OS is to make that execution safe, reliable, and trustworthy. Decision trace. Recording every decision. Execution is not the end of the story. What truly matters is preserving a complete record of what happened. This is the role of decision trace. Every decision, every action, every state transition, and every outcome is recorded in chronological order. Because of this, the entire history of execution can always be reconstructed. At any time, we can answer 4 essential questions. Why was this decision made? Who was involved? When did it happen? And what was the final result? Decision trace is far more than a system log. It is a complete record of how decisions were made and how the system behaved. This foundation makes AI systems transparent, accountable, and explainable. When something goes wrong, we can trace the root cause. When an audit is required, the evidence already exists. When the same situation occurs again, previous decisions can be reproduced consistently, and by learning from past executions, the entire system can improve over time. In other words, decision trace is the memory of Runtime OS. It transforms every execution into knowledge. It transforms every decision into a reusable asset, and it provides the foundation for trust in the age of AI. Because trustworthy AI is not defined only by making good decisions, it is defined by being able to explain, reproduce, and continuously improve those decisions over time. Runtime OS, the complete flow. As we've seen so far, Runtime OS is much more than an AI framework. It is the execution foundation that connects AI with the real world. Everything begins with an event. Signals are interpreted and transformed into meaningful understanding. The current state of the system is continuously managed. Boundaries are verified before any action is taken. Runtime then selects the next decision. Coordinates AI, humans, organizations, and rules, requests human approval when necessary, executes the chosen action safely, and finally records every step through decision trace. Together, these components form a complete execution life cycle. But this is only the overall architecture. To truly understand Runtime OS, we need to look inside each component and see how they work together to enable safe, transparent, and trustworthy AI execution. Let's explore the runtime architecture step by step. Runtime OS, keeping AI safe and under control. Throughout this presentation, we've explored the concept of Runtime OS. Now I'd like to leave you with one central idea. Runtime OS is not designed to make AI more powerful. It is designed to make AI safe, trustworthy, and controllable. Its purpose is to ensure that AI never operates without oversight, that it respects rules and boundaries, that humans remain involved whenever critical decisions require judgment, that every decision and every action can be traced and explained, and that multiple AI systems, people, and organizations can work together with confidence. Runtime OS brings all of these capabilities together into a single execution foundation. As we move into the AI era, success will not be determined by larger models or more data alone. It will be determined by whether we can build execution environments that people can trust. Because the future of AI is not simply about creating more intelligence. It is about creating intelligence that operates safely, responsibly, and transparently. That is the vision of Runtime OS. From decision trace to Runtime OS. Runtime OS is not the end of the vision I have been presenting. It is one of the foundations for a new era of intelligent society. Everything begins with the decision trace model. Every decision is recorded. Every decision can be explained. Why was it made? Who made it? When did it happen? And how was it reached? When decisions become transparent and accountable, they create trust. That trust becomes the foundation of a trust infrastructure, a system where verification, assurance, evaluation, and governance enable people and AI to collaborate with confidence. But trusted knowledge should never remain isolated. Knowledge must connect. It must flow. It must be shared. When knowledge moves across people, organizations, and AI systems, it becomes a knowledge infrastructure, a foundation for collective intelligence and continuous learning. Finally, that knowledge must be put into action safely in the real world. That is the role of Runtime OS. Runtime OS is the execution foundation that enables AI, humans, organizations, and rules to work together safely, transparently, and responsibly. Together, these four concepts form a single progression: decision trace model, trust infrastructure, knowledge infrastructure, Runtime OS. This is the path toward building intelligent systems that people can truly trust. What lies ahead? Runtime OS is not the final destination of the vision I am pursuing. It is the beginning. With Runtime OS, AI, humans, organizations, rules, and the physical world can work together safely and responsibly. But the real transformation begins after that. As Runtime OS becomes part of society, a new form of coordination becomes possible. People and AI, organizations, communities, and even nations, all connected through shared trust, common rules, and transparent collaboration. I call this Runtime Society. It is a society where humans and AI do not compete with each other. Instead, they complement one another, they co-create, they coexist, and they evolve together. As knowledge, trust, and meaning begin to flow freely throughout society, an entirely new form of intelligence can emerge. I call this the intelligence field. Intelligence is not something that exists only inside an individual mind, nor is it something that belongs only to AI. Intelligence emerges when people and AI are connected, when knowledge is shared, when trust is established, and when meaning flows across the entire system. That is the future I envision, a future built on decision trace, strengthened by trust infrastructure, connected through knowledge infrastructure, enabled by Runtime OS, expanded into Runtime Society, and ultimately evolving into the intelligence field. This is not simply a new technology, it is a new foundation for how humans and AI will create the future together. Closing. Thank you very much for watching. At Chinoba, we are exploring the foundations of a new society for the age of AI. Our research spans four core concepts: decision trace model, trust infrastructure, knowledge infrastructure, and Runtime OS. Together, these ideas explore how humans and AI can collaborate safely, transparently, and with trust. If you would like to learn more, you'll find our research papers, books, articles, videos, and the latest updates at chinoba.org. We invite you to explore our work and join us in shaping the future of human-AI collaboration. Thank you again for watching. We look forward to seeing you in the next video. Chinoba, Runtime Society and Coordination Systems.